Okay, so chapter number 4 is about numerical description of the data. Why we are doing this? To measure the center, the measure variability, and shape. So basically, these are the three characteristics we would like to see in the data. Center, where is the data value concentrated? What seems to be typical middle data values? Is there central tendency? So basically, we would like to check the center, how the data is varying, means how much dispersion is there in the data, how spread out are the data values, are their unusual values like outlier, shape, data value distributed symmetric or skewed left right, or it has peak, it is flat, bimodal, multimodal. So these three characteristics we would like to check in this chapter. So very first thing that you have, you know, you have studied or since your childhood is mean, or so basically this is the mean formula, which is average also. So what is the mean, what is the average. In this gonna be pretty much histogram. Then histogram is one part. Here we are going to do numerical description. So in earlier chapter or previous class we described the data visually. Now we are going to look into the numbers. Based on numbers, you can understand the data, you can understand the behavior of the data, you can understand the variability, you can understand the shape, you can understand these three characteristics. So first three things are mean, mode, median. What is mean, what is mode, what is median? Do you remember? Again, in all these slides, you will see population mean and you will see the sample mean. What is the difference between population mean and what is sample mean? Do you remember? Always, I'm just going to give you always throughout here, this is the symbol of population size or population. This small is the sample. So look into the difference. This is nothing else capital N. This mu is this population mean is represented by mu. Here this is represented by x bar. So four notations I'm again telling you: n, mu, sigma, and pi. These are the four important notations we use in population: small n, x bar, small s, and p. So basically this is proportion, this is standard deviation, this is for population, this is for sample, mu, and this is mean, population and sample. So this is population, this is sample, this is population size capital N, sample size small n. Always remember, because by these notations you can easily understand. What is median? So yeah, what is mean? Mean is nothing but an average of all the items or all the observation. So if I ask the average age of the class, I will take individual age of every student, I will sum all of them, then I divided number of student in the class and I will get so mean is nothing but average. What is a median? Median is the central value, center point of the data. Then how it works? Can we take the median? So suppose I want to take the median age of my class, what I will do? First, I will arrange the data in order. First, I will arrange the data or age numbers that I collect of my student in order from smallest to highest. And the center point of that, if suppose there are 25 students, the 13th value, 13th number is the median. So the center, if there are two or even numbers are there in observation, then the average of two middle numbers, which is, let's say, 26, so 13 and 14th, the average of 13 and 14th number will be the median. What is the mode? If you don't understand what I'm trying, I'm as assuming that you all studied these basic concept in your earlier classes or earlier, therefore I'm not explaining with calculations. What is the mode? Mode is the most frequent value in the data. Let's say in my 60 students class, there are 10 students whose age is, let's say, 22, and that is the highest. So that is the highest repeated value or highest most frequent occurring data value in this data. Therefore the mode would be 22 because that is coming 10 times. No other value, no other age is coming 10 times. So the mode is most frequent occurring data value in the data. Okay, so these are the three important uh, univariate data analysis. Why univariate? So if you remember the previous class, there are three types of analysis: univariate, bivariate, and multivariate. Here what we are going to do in these all three, because these are all univariate, you are just going to deal with one variable at a time. Now look into this most important slide from exam point of view also. Look into that. When mean equal to median equal to mode, then you get ideal situation, symmetric situation. So the question normally you will have, if you have mean equal to this much, mode equal to this much, median equal to this much, what kind of shape it will have, whether shape would be skewed left, right, or symmetric, or this. So basically this slide or this data, this three graphs will give you lot of understanding. Based on mean, mode, median, you can get to know the shape. Yeah, so basically we don't have any, study guide is chapter 1 to 4. 1 to 4, that is it is take home exam, 2 hours exam. Let me finish first this chapter, then I will talk about the exam. Okay, this is the most easiest exam, because next 4 chapters from chapter 5 to 8 are going to be difficult, because they are based on probability, and that is not an easy task to do. Therefore I'm going to put a lot of emphasis. So this is the most easiest part of the subject, and you can score almost 100 out of 100 in this. This is take home exam. This is also all flexibility is there with you. Okay, yeah. So if you have higher mode and a smaller mean, then you can say this is skewed left. If you have highest mean is highest among mean, mode, median, and mode is low, median is middle, then you can say this is skewed right. So based on all three, mean, mode, median, you can judge, you can understand the shape of the data. It is skewed left, right, or symmetric. And this is the ideal situation when mean equal to mode equal to median. You can blindly say the data is symmetric. Now the next thing is about geometric mean. What is geometric mean? Geometric mean is not, see, geometric mean is not simply used in simple calculation. This is normally used in growth rate related time series data. So growth rate, a variation of geometric mean used to find the average growth rate for time series. And the formula is like this. For example, 2006 to 2010 JetBlue Airlines revenues are, and these are the revenues. What is the average growth rate? So what normally people do, they this plus this plus this plus this plus this divided by 5. No, that is not the case. Whenever you do any growth related in finance, in economics, in business, growth related time series average, you need to always use geometric mean. And geometric mean formula is like this: gr equal to square root, if there are 4. So this is the formula. So this is the formula: n minus 1 if there are 5 data of data values, xn divided by x1 minus 1. So this is, or you just multiply all of them, square root this. So this is geometric mean. How do we do? I'm going to explain. In our calculator, we are going to also work on. We have this in our Minitab also. So I request all of you to kindly mute your microphones. So basically, this is geometric mean formula. So mean, mode, median, and geometric mean. So these are the four important things. Now, fifth part is mid-range. What is the mid-range? Mid-range is the minimum value plus maximum value divided by 2. And that is mid-range. So here is the mid-range, highest value, high, and then, so that is mid-range. Is the point halfway between the lowest and highest value of x. So this is very simple. You take highest value, and actually everything you can get on our Minitab. You don't need to do anything by hand or by calculator. So trimmed mean is another important thing. Though I will not ask this in exam, but you need to know this, what is the trimmed mean. So for example, if there are some unusual values, there are some unusual points at the beginning of the data and at the end of the data, then those can be trimmed. You can trim 5%, 10%, means 5% on the beginning, 5% on the end, and then you can get the middle data, and which middle data can be used for data analysis. That is trimmed mean. So here also, that is we do. So this is not important from exam point of view, but normally this you need to know what is trimmed mean. Now we are going to come on very important aspect, which is variability or variation. So what is the range in variation? How the data is spreaded? So very simple. What is the age of my class students? So somebody is 20 years old, somebody is like 27, 29. So what is the range? From 29 to 20. It's a 9 years is the range of my class students. in terms of age. So this is called, first thing in variability is range. What is the range? How big is the range? How long the data is spreaded? So that is variability. Now, very important concept, which is called standard deviation or variance. If you remember, if you have studied in your past classes, let me explain this very simply. What is standard deviation and what is variance? They have only one simple thing, See, this is variance. Sigma square is variance, but again, the sigma value is here. That means this is the variance of population. Here you can see small s is there. That is the variance of sample. Now you look into the standard deviation. What is the difference? Sigma is the standard deviation of the population, standard deviation of sample. So this you can simply understand. Look into the what is the difference between this variance and the standard deviation. Variance, you can see there is no square root. You can see there is no square root, but here sigma square is there. So if you want to remove if I want to remove this square part, I will do square root. If I want to remove this, I will do square root. So this becomes so yeah, so you can see there is no difference except removing the square part from sigma, and then so this is the relationship between variance and standard deviation. Now let me tell you, how do we explain, how do we interpret the standard deviation and variance part? If suppose, because two values or two items are very important in all the statistics, one is mean and one is standard deviation. What is these two? Mean, please bear with my handwriting, because and standard deviation, SD, we call it SD. Or so let me go on the simple white page and let me explain. News here. Okay, here you go. Okay, let's understand. This is, let's say, a runway of an aeroplane, or and this is the center point, center line. What So what is this? This is center point, center line, and this is the runway of aeroplane. So most of the aeroplane in the world, they follow this line. When they take off, their front landing gear is always on this, this line, and when they land, their front landing gear, front wheel is always on this. Okay, my dear friend. So this is in simple. Then I'm going to show you the calculation also. So this is the always practice. Now look into that. If suppose the front wheel is here, so this is A situation, this is B situation, this is, let's say, C situation. Oh, I'm sorry. Erase. This is C situation. Look into that. Okay. This deviation, this is the mean. So this is the deviation from mean. This is the deviation from mean. So my dear friends, can you tell me which is the best, where suppose the first plane is following this line, A line. Okay. A line means this A is mean and their actual, they are also following exactly the same. There's no risk, means no risk of having any accident. B is having slighter risk because it is away from the mean. It has chances to go out of the runway. The C is having bigger risk from going out of the runway. So the deviation from deviation from the mean, higher is the deviation from the mean, is not not consistent in the data. So what is the ideal situation? So basically this is called deviation from mean. So this is, let's say this is the another flight landing, which is D. D has almost chances to have an accident. So similarly, I explained sigma value. If sigma value is 0, that means that is ideal situation. So what is the ideal situation? 0. Practically, this is not possible in life. Reason is that nothing is ideal. So what is the ideal value? What is the ideal value? Ideal value is close to 0. Close to 0. So what is the ideal value of sigma? So you can understand from sigma that how good is the data. So if sigma value is higher, then I'm going to explain in numbers also. Then what you say, that the inconsistency in the data, or the data is spreaded, or it doesn't have the consistency. If sigma value is lower, which is good. What is the lower value? If 0, which is ideal, but it is as close to 0. And based on the sigma, there is a Six Sigma concept, which I will explain. And another thing is here that sigma square is variance. So you can simply understand, if you know the variance value, you can square root and you can get the standard deviation. If you know the standard deviation and you can square that, you get the variance. So this is very simple relationship. Now third thing in this, because this is most important concept in entire statistics, which is based on this sigma is used in quality control. This sigma is used in many analysis. So mean and sigma, these are the two important things. Mean is represented in population this, and sigma is this. Okay. So what is the best thing? Always follow the ideal thing. Now let me explain. Okay. So I'm just using some. So let's say I'm just using 3-4 numbers in order to calculate, and you can understand why we are calling deviation from mean. Let's say somebody is 5. I'm using very simple numbers so that even you can crunch. 7 is, let it be 6. 5 plus 4, 9, plus 6, 15, plus 7. 15 plus 7 is 22, plus 8. So 1, 2, 3, 4, 5, 6. Okay. The total is 30. What is the average of this? Average is divided by 5, which is 6. Okay. Now 5 minus 6. So this is 4 minus 6. This is 6 minus 6. 7 minus 6. And 8 minus 6. I'm just subtracting the average mean of from each value. What am I going to get here? Minus 1. Because here we get minus 2. Here we get 0. Here 1 and 2. Okay. What if I do here I just sum all of them? What am I going to do? I'm going to get 0 because these two values are negative, these two values are positive. Minus 3 plus 3 becomes 0 now. Therefore, what am I going to do? I'm just going to make the square of this. So this is 1 square, 1 plus 1, 2 minus 2 into minus 2, 4. Sorry, this is 4. Please. Okay. Draw. Okay, so this is 4. 0 square is 0. Again 1 and 4. What am I going to get here? 4, 5 plus 5 is 10. Are you with me? What am I going to get here? 10. If I do the average right here, then the entire thing is 0 and we don't have any further calculation, and there is no possibility. Therefore, we made the square of this. Now next thing is, I just show you so that news here. So this is the formula. Let's say x minus mu, which I did, or x minus x bar square that we did, divided by n minus 1 in case of sample, and divided by n in case of population. So let's do this. So we did this sum of x minus mu square. Now we are going to divide with n. And now I go to share my whiteboard. So this is the 10 divided by, I'm just using the formula of 5. What am I going to get? This is going to get, I'm going to get 2. Okay. So what is the value in this? This is the value of sigma square. That means what is the value? Variance is 2. Now I want to get this sigma. So what I will do? I will do square root of 2. And you will get to know this is 1 point something would be the standard deviation of this data. So this is the simple calculation in this case. Now think another situation. I'm going to make it clear. Think about if all the values here are, in my class, all the students are exactly of same age. So I will say this is 5 years old. Just a minute. Someone is 5. He is also 5. 5, 5. What is the average? Average is 5. If I subtract from 5, this is the ideal case, which is not possible. Then, so this is going to be, all are going to be 0. We are going to get 0, means look into that. So what is this value? Even this value is going to be 0. means variance is going to be 0, means standard deviation is going to be 0. Practically, that is not possible in nowadays. Therefore, what is the ideal value of sigma? Sigma is 0, but as close to 0 is better the sigma values, better the data. So you can understand using sigma or variance. Is it making sense? Everyone in the class, are you getting this concept? What is the sigma? And so let me give one more example. Let's say this is, for example, like I gave the runway. So runway from, from this is like 20 meter. This, the ideal is this is 20 meter. The whole, runway width is 10. And the center point is 10 meter, at 10 meter. Okay. So this is 10. 10 is, so we get the 10 is the mean. And suppose each flight is, landing and front wheel is like 10.1. Someone is 10.0. Another is 10.2. 10.0, 10. So these are the 5 planes. They are they landed and their front wheel is on this. Then I subtract 10. So basically, what is the value here? I get 0.1. This is 0. This is 0, 0.2, 0 and 0. So basically 0.1 and 0.2, when we do calculate, it comes very small. If suppose these values are also 10 and these are also 10, we get every value 0, means sigma is 0, means ideally all the planes are landing exactly on the center line of the runway. So therefore this is called standard deviation. Some people also call deviation from the mean, how much it is deviating from the mean. And this is the formula. This is the variance and deviation. You can understand this, but I solved simply by using 5 numbers. Actually, why I'm explaining these concepts, because in Minitab you can get these numbers just using one click. What is the here coefficient of variation? What is the coefficient of variation is equal to 100 multiplied by standard deviation divided by mean. So this is the formula, or this is the equation: 100 multiplied by standard deviation divided by mean. Mean absolute deviation, this is another important concept that you need to understand. Why we use standard, why we do a square? Because if we don't do a square in a standard deviation, we are going to get a 0 at the end of the day. Therefore this concept is called mean absolute deviation. Instead of doing the square of the difference between actual and mean, they do the absolute value. How? Let me explain here. So like I took 5, 6, 7, 8, 1, 2, 3, 4. So 5 plus 6, 11, plus 7, 18, plus 8, 18 plus 8 is 26, and this is, let it be 4. So this is 30. The average is 6. Let me do this 6 from here. Minus 6, minus 6, minus 6, minus 6. What we are getting here? minus 1. What we are getting here? 0, 1, 2, and minus 2. So try to understand, sorry, minus 2 and, yeah, 2 and minus 2. If I sum all of them, they are going to be 0. Therefore, instead of doing this, why don't we take the absolute value of this? So absolute value is like this. You are putting two vertical line. That means the importance of signs, a sign like minus plus becomes null. So 2 plus 2 plus 1 plus 1. What is the mean absolute deviation here? 6, because 1 plus 1 2 plus 2 4 plus 2 6 divided by what is the n? We have 5. So this would be known as 1.2 would be mean absolute deviation. This is also used in some cases. We are doing, instead of making a square of these values, we are making a absolute numbers right here. Can you show how you get 6? Okay, Bira. So 5 plus 6, 11 plus 7, 18 plus 8, 26, 26 plus 4, 30. 30 is the sum of all. We would like to take the mean. How many values are there? 1, 2, 3, 4, 5. So what is the average or what is the mean of this? Mean of this is 6. Therefore, so this is mean absolute deviation. And some cases this is also used. Not important as some standard deviation, but yeah. So actually I'm not. Now here another important thing which we will start little bit later. Let me go on Minitab. So this is our Minitab, as you know. Okay. And from where I got the data, right here, you can look into the chapter Word document, and here, this is the data, and this is Minitab file. So I just downloaded and I'm using. Okay. So this is the data. And now I'm going to go here. Please put your attention here. Statistics. This is the fifth column, fifth option. Why this is statistics basic is okay. Since this is, let me make it. Statistics, basic statistics, display descriptive statistics. The moment you do this, and then you need to select the variable. So let me select the variable, only one variable, GRE score. Here, when you click the statistics, can you see this? Why this is here? Can you see this? Please move this window away from the shared application. Okay, let me do one more time. I think something is news here. Screen. Can you see now my Minitab? Okay. So here, when you go on statistics, basic statistics, display descriptive statistics. So only three options: stat, basic stat, and display descriptive statistics. Right here, I need to select for which variable I need to do analysis. So I'm just selecting, for example, GRE. When you select GRE, here you have all the options. Can you see? So far what we have studied? We have studied mean. Okay, let me unselect all of them. Okay, so nothing is selected. What we have studied? Mean. Okay, we have studied variance. We have studied the standard deviation. We have studied the median. We have studied the mode. What else we did? Minimum values, maximum values, range, and we are coming on these things. What else? So coefficient of variation, interquartile range, first quartile we have not studied so far, percent. Okay, so we did almost these things. Is it clear to everyone? Now I'm going to click OK button and then OK. Look into that. Whatever I explained in last 40 minutes, I can get in just less than few seconds, less than a minute. Here you can see what is the mean. 316.47. This is the mean of all the observations. Standard deviation is this. Variance is this. So if you square root of variance, you will get 11.3. If you square the standard deviation, you will get the variance. So basically they have the relation which you can understand, square root and square. Coefficient of variation 3.57. What is the coefficient of variation? I explained. What is the minimum value in the data range? 290. What is the maximum value? Is 340. 340 is the maximum, 290 is this. So highest minus lowest. So this is the range, which is highest is 340 minus 290, which is 50 is more range. Mode, what is the mode? Most frequent occurring number in any data. So basically 312 is coming 24 times. How many times is coming? 20. What is the median? Median is 317. Means when you arrange the data in order, the center point is 317. So 290 is highest. This is 290 is minimum. 340 is maximum. So basically you can just do this. 290. Let me do this here. This is, let's say, 290. Please. This is 340. So this is the starting point. This is the end point. In center is 317. Okay. So basically this is what we have studied, and you can select carefully. Is it clear to everyone? How do we do this? Now look into the exactly same thing. Clear all the drawing. And now let me go with my calculator, Texas Instrument, TI. Hope you can see. Can you see my Texas Instrument calculator? Okay, great. So let me maths. Here you can see here around so here we have number and maths. Before that I need to go just a minute. So first I need to enter the data that I can get from a spreadsheet here. Yeah, this is the statistics. So can you see the statistics is right here? This is the option of stat. Now I need to enter the edit. The moment I press the enter button, I get the numbers that I need to put. So basically in calculator, you don't have option of copy paste. Let me do myself. 6, 7, 5, 8, 4. Can you see this? I've entered all these 4 numbers right here. 6, 7 that we used in our calculation. So we know our data is right here in L1 column. L1 column. Now again I go on stat. Where is the stat again here? Here, then you have option calculate. What we have here? Calculate. Now here we have one variable statistics, two variable statistics. So in chapter 4, what we are doing so far? One variable statistics. So I just press here, one variable statistics. From where I need to get the data. So here by default it is getting from 1L1, and then calculate. I press the calculate button, and here I get the answer. Can you see this? What is the mean? What is the mean here? 6. What is the sum of all? 30. I hope you can see this. What is the EX is 190, SX is 1.58, sigma X is 1.41, number of observation is minimum is 4 value. Here, just let me. So why it is not good? I would like to go again here, stat. I have the data right in the one variable statistics. Enter. So minimum value is this much. Here basically it will go down. So where is the go down button? Just a minute. Yeah, so if you see, this is the option. Yeah, this is the one. Yeah. So here you go. Minimum value is 4. Q1 is 4.5. This is quartile range, which we have not started. Median is 6 because 6 is the center point here. Quartile 3 is 7.5. Maximum value is 8. Now here you just see two values are here. Let me. Which is the correct value? Which is the standard deviation? Can you understand here? Sx is 1.58, sigma x is 1.41. Which one is correct? Which one is correct? Any guess? Bottom. So Brian is saying bottom is correct. Okay, Bira is also saying. Why? You remember two formulas. For population, the denominator is capital N. For sample, denominator is n minus 1. So basically this is population 1. This is population standard deviation and this is sample. Clearly understand, this is sample, this is population. Why? Because if you denominate whatever is number subtracted with 1, so this denominator is smaller, then total value will be higher. This is right here. So this is the difference. Whenever asked what is the population standard deviation in calculator, you need to answer this. So this is a population standard deviation, this is a sample standard deviation. Whatever is smaller, that is a population. Whatever is little bit bigger as compared to that, that is sample. Is it making sense? So you can do in this calculator also. Let me show you the same thing on the slide also. Where am I? Here you can see. Here you can you see this? If you can see, this is divided by capital N, n minus 1. You can see upper part is exactly the same in both. Here it is divided by capital N, here is divided by small n minus 1. So here numerator is little bit bigger in this, and here numerator is smaller. Okay, so these are the first part of the chapter. Now let's look into the second part of. So this is an important theorem, Chebyshev theorem, whether I'm able to pronounce properly or not. So this theorem, for any population with mu is mean and standard deviation sigma, the percent of observation that lie within k standard deviation of the mean must be at least 100 1 minus 1 upon k square. K equal to 2 standard deviation, 100 1 minus 1 upon 2, which is 75% of data. So at least 75% will lie within 2 standard deviation. What is this? I'm going to explain. For k equal to 3, at least 90%, 88.9, which is, you can say, approximately 80% of the data must be within that range. And then, so basically within 1 sigma, it says, then actually this is the truth, which is empirical rule. Within 1 sigma, it has to be 68.26%. Within 2 sigma, 2 plus minus sigma, it has to be 95.44% and 99.73%, which is 6 sigma. So I'm going to explain these two rules and then we will understand. So for any data, any values, look into this. Can you see? This is the mu. What is mu? Mu is the average of population or mean of the population. So this is the mean. From this side of the mean is positive side. From this side of the mean is negative side of the. So this is, for example, just take a look. This is the mean or average. This is center point of the distribution. Here, this is 1 sigma. Whatever is the value of standard deviation. So mu plus 1 sigma, whatever is the standard deviation value multiplied by 2 plus average. So this is positive side. This is known as positive side. This is known as negative side. From here, within 6 sigma. So this is 3 sigma is here. 1 sigma, 2 sigma, 3 sigma, 1 sigma, 2 sigma, 3 sigma. Within 6 sigma, how much? 99.73% data must be here. This is empirical rule. 2 sigma and 2 sigma. This is 4 sigma. Within 4 sigma, 95.44%. Within 1 sigma means 2 sigma, 68.26% data must be here. Is it making sense? I'm going to demonstrate on Minitab also. So this is, we are going to work lot of on this principle in next couple of chapters, which is 6, 7 and 8. So this is very important to understand. Then standardized variable, which is called Z, redefines C's observation in terms of number of standard deviation from mean. So this is Z value is equal to individual value minus the population mean divided by standard deviation. A standardized formula for sample, exactly the same here. This is population mean and population standard deviation. This is sample mean, sample standard deviation. Positive Z means the observation is on the right side of the values, right side of the mean. Z is negative, then it is left side of the mean. So this is, so for example, this is the mean. If Z value is coming on this side, it is positive. If it is coming this side, it is negative. Though this is just basic concept, and we will do a lot about this in next chapter number 7 or 8. Estimating sigma. So how do you estimate the sigma? Basically, sigma is 3 sigma or 6 sigma. Look into this. This is from here to here, in 6 sigma range, how much observation, how much data is coming? Almost full, almost 100%, close to 100%, which is 99.73. So this is basically a range. So this is range. Whenever you don't understand any concept, please let me know so that I can explain. So this is entire range because all the data almost coming in this. Range is equal to 6 sigma, or I can write here range equal to 6 sigma. You can say within 6 sigma. So what about the sigma? Sigma equal to R, then 6 will come underneath of this, R divided by 6. Is it making sense? So how do you so sigma equal to R upon 6. Basically, we can get to know the range, and based on range also you can calculate the sigma. So if this is clear, let me go on Minitab to demonstrate this. I hope you can see my Minitab. Is it visible? Here you can see under graph. Under graph is probability distribution. That is called here. Okay. So I'm just going to demonstrate this. Here you can see probability, and I'm just going to show you. Can you? So this is just normal probability distribution. This is positive side, this is negative side, and you can play with this. Lot of graphs can be made. So I'm just going to do another one. I'm not using any data as of now. This is just I'm going with. So now here we have shaded area. Now I'm going to do middle. I need middle how much? So Just a minute. So mean, I think I'm just going little bit advanced in order to explain. Just let me go with only this GRE score. Stat basic is here. We have a graph histogram. Let me go with okay, and let me go with GRE, and I can do the all the labels and everything. So look into. Can you see this? Is simple histogram of GRE, and you can see on the top of that the normal distribution. Here you can understand this is a mean, this is a standard deviation, number of observations are 500. So this is one thing. So you know the standard deviation. What is the standard deviation here? Now let's do the simple calculation. Mu plus 3 sigma is the and mu minus 3 sigma. This is the limit, or this is the range. So mu is 316, which is right here, plus 0.5. Please follow me. And now I'm just going to use the calculator to 11.3 multiplied by what is the standard 11.3. So 316.5 plus 11 multiplied by 3, so 33.9. How much we are getting? 316 plus 33, which is 316 and 9 20 plus 30 49 50 350.4. If I am wrong, please correct me. So this is the upper limit, and what is the lower limit? So 316 minus 33.9. So if I subtract this 33 from this, how much we are going to get? Let me do this. Just a minute. So where's calculator? So tools, calculator right here. 316.5 minus 33.9, which is going to be 282 minus 6. Now, my dear friend, what it says, between 282 to 282.6, I'm just going to say to 350, almost all the data will come into this. Almost 99.7% data will come in this. This is the empirical rule, if I'm correct. Between this range, all the data will come. Now look into that practically. So I'm just going to arrange this data in an order, and let's see manually how much number are coming. So remember these two numbers, 282 and 350. Clear all the drawing. And now so I'm going to data, and I'm going to sort this data, sort the data. What I am going to do, which is I'm just using GRE score, select. I'm going to use increasing, and at the end of the current seat. So I'm just going to place this at the end of current seat. So basically, where am I? So GRE. So here the serial number has been changed. So 290 is the lowest one, if I can see. And if I go from 290 to look into that, 300, and then it is saying about 300, I think 50. So 340 means our all the data is coming in our range. 99.7 means nothing is escaping from our range. 280 to, so it says empirical rule says 99.7, and we practically are able to see 100%, almost 100% data is coming in 280 to 280 to what, 350 range, means all the data is within. Now let's check the two deviation rule. Clear all the drawing. What is this? 316 plus 11.36 plus how much? 11 means 22.6. 22.6. So this is 0.5, and this is 1 plus 6 plus 2 8 plus 1 9, 3 and 3. So between 339, this is the upper limit, and lower limit, let me subtract this. So how much we are getting here? 316.5 minus 22.6, we are getting here 293.9. 293.9 to 339.1. So let me see between this range how many numbers we are getting out of 500. Okay, let's see the range here. Where is GRE score? 294. Okay, so just see. So 293. So this is not coming. This is not coming. Is this coming? So first three numbers are not coming in our range. Okay. Now let's go at the last 339 point. So basically 330. Three numbers are not coming, and 340. How many are there? 1, 2, 3. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many? 92 to 5, which is 9 plus 3, 12 numbers are not coming. So let me do the calculation. 12 are not coming out of 500. 12 are not in the range out of 500. I'm just roughly doing whether this is fitting in 95%. So how much is this percentage out of? It is close to 95%. It is, I think, 92%. So to more than, so basically this is coming around 97 or 98%, between 97 and 98%. So it says 95%, 95.5% data must be here. Similarly, let's do for 1 sigma. So 1 sigma is how much? 316 plus 11, which is 316 plus 11, which is 7 to 3.8, 327.8, and lower is, if I, so which is 300, 1 2. So I can just round up it to 3.5, 305, 305 to 328. How many datas are coming? So look into that. So I hope you are following, understanding what I'm trying to explain here, because this is another important. So 305, we don't have here 305 right here. So let's count this. So how many 87 points are gone here this side? And now look into here. How much was 327, I think. Yeah, it was 327. So, and then how much is gone from here? So basically 418. So if I round up to, this is going to be 683. 83 is here. And what is, how many numbers were there earlier? 305. 88. So 88 plus 83, how much? 88 plus 83, 171. 171. What is the percentage out of 500? Divided by 500. Oh, sorry, 171. So this is coming 34%. Basically, this is coming 34% data is not in the range. And what is the thing this that called within 1 sigma 68% data must be there, 68 point something. So basically if you do this, which is coming close to 6, so we are doing with only 500 numbers. If you do with 100,000, if you do with couple of thousand numbers, you will get exactly this empirical rule in the practical. So look into this, whereas it says 99.7, 95, 68. So we are getting close to this number based on only 500 observation. Is it making sense, my dear friends? Is it making sense? Please, we will learn about this topic more in the chapter number 7 and 8. Will it be covered in the exam? Calculation will not be covered in the exam. Certainly, because chapter 1 to 4, whatever simple numbers are there, that will be. We will not do the calculation. Calculation we will do in chapter 7 and 8. However, you need to remember what is the value range of 6 sigma, 4 sigma, and 2 sigma. Now look into this. This is z value. You can get your value, and this is useful in your getting your percentile and other things. So based on that, you can, based on mu and sigma, you can know where you are. So let's see. For example, this is 316. This is standard deviation. Look into that, where this person stands. So where is what is the value of 331? 331 in this distribution. So what we will do, 300 331 minus what is the mean, 316, divided by 11.30. What we are getting here, this is coming in positive, because 330 13 plus minus 5, so 16. How much is this going to be? 314, sorry 14.5, 14.5 divided by 11.30. So if I calculate all this value, what is this? 14, it is going to be 1 plus something. That means this is going to be on the right hand side, on the positive side. If suppose this value is less than that, automatically it will go on the negative side. So by knowing the mean, by knowing the standard deviation, you can understand where is the value, it is the positive side or negative side. I'm not going to cover much in this. So this is z value. We will do this in chapter 7 or 8 more. Now we are going to learn a very important thing which is called percentile. What we are going to learn? Percentile. Okay. So you learned median. What is the median? What is the median? So in very simple way, I'm going to explain on my, so let's say this is our data. You arrange the data in exactly. So if you arrange this data, this is minimum, maximum and minimum. This is the middle point of the data. This is called median. So this is median, means means you have the data. If you divide this data into two pieces, like Brian says median plus, so this is 50%. If you divide into two pieces, this is the role of median. Okay. Now look into, I just take this only this range, and I divide this into two pieces. This is first piece, and again I take only this area and I divide this into two pieces. So this is 1/4, this is 2/4, this is 3/4, this is 4/4. So basically if I do the median of this range, entire range, and I divide this into this is the range. Okay. So this is called Q1, this is called median or Q2, and this is called Q3. Are you getting me? So first you take and divide in two pieces, that is a 50% median, and then again take the first 50% and divide into two pieces, that is called, so this is called quartiles. Quartiles means if you divide this data or you chop this data into 4 equal pieces, that is called quartiles, means 4 quarters. Okay. Now similarly, if you take this data and divide into 10 equal pieces, 2, 3, 4, 5, 6, 7, 8, 9, and please understand this is 10. So if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If you divide this data into 10 equal pieces, this is called decile. Okay. Similarly, if you divide this data into 100 equal pieces, I mean, please understand these are going to be 100, though I'm not able to draw all 100. Then that is called percentile, because that is 100 pieces. Is it making sense to everyone? So if you divide into two pieces, that is median. 50%. If you divide into 4 equal pieces, that is quartiles. If you divide into 10 equal pieces, that is decile. If you divide into 100 equal pieces, that is percentile. Okay, now look into this. So percentile are the data that have been divided into 100 groups. So your score is 83rd percentile on the standard test. That means 83% of the test takers scored below you. So when do we use this percentile? We use in SAT score. So I'm going to show you how do we do that. Decile are data that have been divided into 10 groups. Quartiles that has been divided into 4 groups, and quintiles is that can be divided into 5 groups. So basically, what is important here? Just a minute. Oh. New share the screen. So can you see this? This is percentile 100 pieces, decile 10 groups, quartiles 4 groups, quintiles is 5 groups. So basically quintiles we don't use often. However, these three are very important. Is it clear? Because in assignment you will have questions in Word document based on that. Now I'm going to show you some other calculation, then we will go on. So percentile 5th 25th, we are going to. So how do we do? This is exactly I did, so you can do that. So lowest, second, third, 20 means this quartile Q1 is the boundary between lowest 25 and second 25. Q2 is the boundary between second and third, and Q3 is between 3 and third and upper quartiles. So how do we do? First you take lower 50% and upper 50% using median, then you do the same thing using, so you can do this. I don't need to do this. So actually there is a box plot is the method which explains 5 number summary that include minimum value, maximum value, Q1, Q2 and Q3. So how do we check Q1, Q2, Q3? Using Q1, this we are going to look into that. So box plot is the 5 number summary which gives you minimum value, maximum value, Q1, Q2 and Q3. Middle 50% is known as interquartile range, means the difference between Q3 and Q1 is known as interquartile range, means middle 50% data is in this range. So yeah, based on this we can check whether it is skewed right, skewed left, or uniform or normal. So look into that, my dear friends. I'm just going to use Minitab again. I hope you can see Minitab, graph, and we have box plot right here. And I'm going to use here again GRE score, scale, and labels. Let me put the data levels, outlier, medians, data value, multiple graph we are not using, data option we are not using. Okay, can you see this? Can you see this? What is the Q1? What is the median? What is the Q3? What is the interquartile range? Whisker we are n equal to 500. 290 is the lowest value and 340 is the highest value. Can you see all these 5, 6? 290 is the lowest, 340 is the highest, Q1 is 308, Q2 is 317, Q3 is 325. So you can do all these 5 numbers using this box plot. And you can edit graphs, and you can add. So basically options, just a minute. Add data levels. Just a minute. This data display, range box. So basically we can do all the levels here. I'm just there's some option, outlet. So you can do that. So I'm not just showing, but here this is the 5 number representation. Now look into the same statistics, basic statistics, display descriptive statistics. I'm going on GRE and I'm clearing all of them. What is important for me is median right here, third quartile, first quartile, interquartile range, and what else we learned? Minimum, maximum, and range. Okay. Okay. So look into that. Minimum is 290, maximum is 340, one is 308, interquartile range is 17. So whatever we studied can be done right here. Now look into that. Middle 50% data can be between 325 to 38. Means what is the difference between 325 to 38 is 17. Lowest data is in the 290 to 308 range. Highest 25% data is between 317 to 325. Highest 75% data is from 308 to 340. 308 to 340, highest 75% data is right here. So I asked the question related to this, where you have highest 10% data, where you have middle 50% of data. So you need to interpret these kind of numbers. You can see the assignment, and basically what is the top 75%, what is the middle 50%. Can you see all these things? If I am asking what is on your understanding of CGPA, that means you need to write what is the minimum value, what is the maximum value, what is the median, mode. Okay. I am just going to take 20 minutes more and then we are done. So where am I? Okay. Yeah, so based on that you can also understand what kind of. So basically we got this kind of uh, box plot. Therefore we can say our data is almost symmetric. If you see the box plot is towards this side, that you can say skewed left, means tail is towards this side. If you see the tail is towards side, you can say skewed right. So you can understand based on box plot what kind of shape is there. So this is interquartile range. Mid hinge is another thing basically. So I'm not going to explain. Then it is a correlation coefficient. It is another important thing. Correlation is bivariate analysis. What am I saying? Bivariate analysis means two variables are used here. The range of correlation is -1 to +1. And this is explained by, just a minute. This is explained by small r. Small r is the representation of the correlation. You don't need to remember all these things. I'm just basically explaining what is the interpretation of all this. So if you see there is a relationship between, so this is x, this is y. If x is increasing and y is increasing, and you can see this is very close to a straight line, therefore r is 90% related. If you see this is also x is increasing, y is increasing, this is 50%. This is not exactly a straight line, but here you don't see that relationship. That means the relationship is zero. X is increasing and y is decreasing, that is negative 90%, means, but it is coming in line. This is exactly opposite, that is negative 50%, and this is no. So correlation is the relationship between two variables, and that can be very easily understand. Let's say if you have income and spending, if you increase, if your income is increasing, certainly you will have is your spending is increasing. That is positive relationship. What is negative relationship? Suppose your income is increasing but your spending is decreasing, that is negative relationship. Suppose you are increasing something but you are decreasing something, that is negative relationship. Similarly this, so any value between -1 to +1 is possible. Minus sign represent the negative relationship, positive sign represent the positive relationship. And so for population, covariance is another thing, which is here represented by this. For correlation and covariance, which is here sigma x by here population, and this is, so covariance is a correlation coefficient is a covariance divided by the product of the standard deviation of the x and y. So covariance measures the degree to which the value of x and y change together. So change in x and change in y, that is denoted by. Group data we are not explaining. Then two other important things are coming here: skewness and kurtosis. Skewness that you have been observing, it is explaining the shape of the data. So basically this is skewness is 0, that means symmetric is, when skewness is greater than 0, that means skewed right. If it is skewed less than 0, that means left. Similarly, this kurtosis is representation of the peak of the data, how it is. If kurtosis is equal to 0, that means it is normal peak. If it is less than 0, it is means heavier tails, means this is platykurtic, or lipokurtic, means if it is greater than 0 means it is very sharp. So these things are there. Let me go and do this on our Minitab. So here we have stat, basic statistics, display descriptive statistics. Again, I'm just using the same thing. I'm just removing these things. So yeah, what I was look into the kurtosis and this. Okay. What is the skewness value is minus 0.04 and kurtosis is minus 0.07. What do you understand from these two numbers? Look into this. Oh, where am I? So it is less than 0, that means skewed left. So skewness is skewed left, and this is little bit flat kind of thing. So this is heavier tails, that means platykurtic. So this is the shape of the kurtosis. Is it making sense? Now we are going to do the correlation. Just a minute, last thing. So what I said, correlation means you need to have two variables together. So I'm just going here, stat, and in stat you have Basic statistics. Under basic statistics, you have correlation at the bottom. Can you see this? Correlation is right there. And under correlation, let me see two variable. So these are the two variables I have seen. And okay, let me do right there. So what is the correlation here? 0.664. This is positive. What is this? The positive 66.4% is the relationship between LOR and SOP. Is it making sense? So this is the last point that I need to explain here. If this is clear, it is going to be recorded. It is already getting recorded. It will be placed on YouTube, and you will get the link also to watch. If you have any question, let me know. Then I'm going to briefly, in 5 minutes, I'm going to talk about exam. So exam will have two parts. One will be you need to make the answers. You need to do the Minitab. You need to place. You need to put your Minitab output into the Word file, and you need to upload. That will be for 1 hour. So few questions will be there that you can just do, and you can explain, and you will. So that is the one part. The second part, you will have multiple choice questions based on chapter 1, 2, 3, 4. And since Minitab is based on 3 and 4, you will get questions from chapter 3 and 4 for Minitab. So two parts, you will have 2 hours. First part will have 20 questions of multiple choice that will test your knowledge and basic understanding about the concept from chapter 1 to 4. And second part will be based on Minitab. So this is the plan. Next week I will. So next class I'm going to make the formal announcement on Canvas so that you can know more about that. Any question? Only 15, 14. Thank you so much. So good night. Bye bye. And I'm going to give you the detail and make the formal announcement so that you can go through. And I'm going to give you sufficient time to so that you can do the exam properly. Bye bye. Thank you.